Okay, so today we're going to be reviewing the steps and process of writing a proof. So, in general, when we're writing a proof, uh, the steps are going to be for the actual writing of the proof, the first thing you want to do is list the givens. And when we're talking about givens, we're not talking about stuff that you can see in the picture. We're talking about the stuff that they actually gave you in the original problem. Uh, so today's practice proof is going to be the diagonals of a parallelogram bisect each other. So the only given in that situation will be that there is a parallelogram. Anything else has to be part of step two. So always start your list of givens. Then you're going to identify things from the picture. This might be the things that where a segment is congruent to itself because of the reflexive property, or you've got vertical angles, or you've got a straight angle, or different things like that. And then when writing the proof, the next step after that is to write down what follows and is true because of steps one and two. So that would be, I mean, part three is really the heart of the proof. It's all the stuff that's in the middle. Um, and then the fourth part of a proof is going to be to write your conclusion. And that's where we wrap up the proof. Remembering to have gone through and check that you've given every statement has some kind of reason for it. That's what you're doing in these parts up here. And then for your conclusion, you always want to write what is the thing that I was asked to prove? And now, what about the picture means that I have actually accomplished that process. So that's the main steps for writing a proof. Your actions around this, right? So you're going to review the picture and the givens. If you don't have a picture, you'll draw a picture. And then you really ought to make a plan. It takes somebody who is incredibly skilled at proofwriting and highly knowledgeable about math to just launch into a problem trying to write a proof about something without a plan. And in the plan, I find it useful to work backward. Start with the end in mind. Start with what you know your conclusion is going to be. And then ask yourself, so we'll write that down. So start with the conclusion, and then ask, what had to be true to make that conclusion? And this is where the work of making your plan becomes iterative, which means it keeps repeating its own process. Because you're going to keep asking that question for each answer that you give. Until you end up back at the Gibbons. And so that's the steps I'm going to be taking for writing the proof today.